Okay, Trig, I'm gone for kindergarten roundup today. I'll be back like halfway through the period, so you guys can ask me questions then if you have them. But we started 6-3 on Wednesday before the snow day, and we kind of talked through the difference between degrees and radians. We're going to finish that topic up and go through some more examples. I'm going to have my sub give you a paper that looks like this, and what a jumbled mess this is. It is a blue sheet of paper, which means it's an important sheet, which means you need to keep track of it. And this is sheet of paper you can use on your test. You three boys that are in calc also have a paper that looks like this that I think is like pink, but you also have derivatives and stuff on the back side of it. You may want to switch over and use this one for trig, because on the back side of this paper it will be blank and we can like take some extra notes on there. So, I mean, you're more than welcome to use your pink one, but it might be better to use this one for trig, just because we'll add stuff to the back. So, all right. I'm going to probably skip over the majority of this page just because it talks about the unit circle here. But we do have one example here, example 2, that we've got to talk through. Some of these next couple problems are going to be a little bit harder, but yeah, when they talk about arc length, like refer back to these examples, okay? So in this one, when we talked on Wednesday, we have our circle, okay? And we said 0 degrees lives here, 90 degrees lives here, 180, 270, and then 270, and then 360 comes back to the center here, okay? In radians, we said 0 radians was here, so I'm going to do 0 radians. But then we said if we went a full circle around and we talk about circumference, that would be 2 pi, because circumference is 2 times pi times r, and if we assume the radius is 1, it would just be 2 pi. So really think of it as like 0 degrees is 0 radians, but 2 pi is equivalent to 360 degrees. Okay, so 2 pi radians is 360 degrees. Now, if 360 is a full circle, 180 is half of a circle, 2 pi is a full circle, 1 pi is half of a circle. Okay, so 1 pi radians would live over here, okay? And then half of a radian, or half of a pi, would be up here at the top, but they call that pi over 2 radians, okay? And then this would be 1.5 pi. They call it 3 pi over 2, because 3 divided by 2 is 1.5. So that's how they have that labeled. If you look on your unit circle, you have those there as well. So here is 0 degrees, 90 degrees, 180 degrees, 270 degrees, but then the radians are 0, pi over 2, pi, and 3 pi over 2. So locate those on your unit circle. That's where your radians and degrees live, okay? And then we'll talk about what this jumbled mess is here eventually. We'll get to that, okay? All right, so go back to that example, and they talk about, it says an arc in a circle has a length L, which is equal to the radius, okay? So what we're talking about when we say like 1 radian, okay? If this length right here is 1, I want to go as far in the circle, this is a number of degrees, so that this distance is the same as this distance. And what it actually equals out to is that around the circle we said was 2 pi, right? And 2 pi as a decimal is 6.28. That means that around the circle, this is one chunk. Here's another chunk. Here's another chunk. Okay, here's another chunk. There are actually 6.28 of those chunks all the way around the circle, right? That's what makes it 2 pi. There are 6.28 lengths of the radius, however far the radius is, all the way around the circle, okay? So like even if my radius of my circle was, let's say 20, right? From here to here would be 20. From here to here would be 20, right? From here to here would be 20. Here to here would be 20, here to here would be 20. It would be like 20 distances all the way around, and there would be 6.28, so almost a quarter of another one all the way around the circle, okay? That's 1, 2, 3, 4, 5, 6, and then 0.28 of those around the circle, those distances around the circle, okay? Now, they're saying find the measure of the central angle for one of those, right? So if I have like just this slice of pie right here, how many degrees is that? Okay, well, if all the way around the circle is 360 degrees, and there are 6.28 of those around the circle, that would mean I would take 360 divided by 6.28, and Let me find a calculator. It's like 57 degrees. I think it's like 56 and change. Divided by 6.28 is 57.3. So 57.3 degrees is what one radius length is. So each one of these is about 57 degrees all the way around, okay? And then this is just like a quarter of that, right? A quarter or 0.28 of the 57 degrees, okay? So I hope that made sense. If that doesn't make sense, we'll refer back to this again, because that's kind of a weird concept for people to think about. But yeah, so if that was hard, it will get a little easier. Let's go to go down to example 3, which is on like the, I don't know, second staple page, okay? This gets a little easier when you're converting. So when they ask you on your homework assignment to convert, this is the example that you're going to refer back to, okay? So each one of these measurements is in radians, and you're going to convert it to degree measure. So it's like going from centimeters, which is like the metric system, to inches, which is the customary system, like what we are used to, okay? We are used to degrees. We're not used to radians. We're going from one conversion to the other, okay? So here's the deal. On the unit circle, we said 0 degrees was here, and 360 degrees is also in the same spot, and 360 is the same thing as 2 pi, but we said 180 degrees was the same thing as 1 pi, right? So when we're converting, this makes it really easy. In example 3 and example 4, all you're doing is you are saying that 180 degrees is equal to 1 pi. Really, you could say 2 pi is equal to 360, but the reduced form is that 180 equals 1 pi. Like if you divide this by 2, 180 equals 1 pi, okay? So when you're converting, you're either going to use the conversion that like pi over 180 are the same as each other, right? Like this is the same equivalent, or you're going to use 180 divided by pi, okay? Regardless of which direction you're converting. Like if you're doing example 3 or example 4, whether you're starting with radians, degrees, you're going to use one of these, okay? And here's how you decide, okay? Here I have a pi on the top, and this is a radian. So when I am converting, I want to use one of these, and the one that I want to use is the one that will cancel with pi. So I want to make sure that the pi is on the bottom. So I'm going to use this bottom one here, and I'm going to say 180 over pi so that this pi will cancel with this one. And then all I have to do is take 180 divided by 5, and I get my degree measure, okay, which I think is like, I don't know, 36 degrees or something like that. Let me see. Yeah, 36 degrees is what he comes out to be, okay? So you want to use the equivalent here. So same thing here. I want to either use pi over 180 or 180 over pi, okay? Pi is going to go on the bottom. So then this cancels with this one, all right? And here I have a 4 left over, so I'm going to take 4 times 180 and then divide that number by 9. So 4 times 180, 4 times 180 and divide by 9, and that's 80 degrees is what that is equivalent to. So 4 pi over 9 radians is the same thing as 80 degrees, okay? All right, same thing here. This one, though, is not in fraction form, so I'm going to make him in fraction form by putting him over 1. That's how we make anything into a fraction. And then again, I'm going to put pi on the bottom and 180 on the top, okay? And then the pi's will cancel. So in this one, I just take 6 times 180, and 6 times 180 is 1,080 degrees. Just like that. There's that. Okay? All right, now I'm converting from degrees. These are all in degree measure. Now to the radian form of that. Okay? Now, if you notice from up top here, the version, or each one that I had, like pi over 5, or 4 pi over 9, or 6 pi, none of those were in decimal form. Like the pi is left in the equation. And we did not go ahead and write 4 over 9 as a decimal, okay? So what you're going to do is when you're converting, you're going to reduce these as far as you can and then just call it quits, right? Okay, so 75 degrees, if I make that into a fraction, over 1, this is kind of like using the train tracky things, right? So we're either going to use pi over 180 or we're going to use 180 over pi, okay? So up above we used this. So down here, when we're converting these guys, we're going to use this bottom one, and here is why. If we do pi over 180, I'm going to put the degree symbol on the 180 because if you notice, degrees is up here and degrees is down here. Those are going to cancel with each other. So it's like degrees are canceling with degrees, kind of like if you're converting inches, you want one on the top, one on the bottom, so they cancel with each other, right? So again, we're going to leave pi. We're not going to multiply him through, and all we're going to do is take 75 and 180 and reduce them as far as we can, okay? So like I know that both of them are divisible by 5. I know that for sure. 75 divided by 5 is 15. Okay, 180 divided by 5 is 36, okay? Now, can those reduce more? Yes, I think they can. If I divide by 3, so 15 divided by 3 is 5, and 36 divided by 3 is 12. Okay, so then I'm just looking to put it all back together. So I have 5 times pi, which is 5 pi, and 1 times 12 on the bottom is 12. Okay, notice I did not write the 5 and the 12 as a decimal, right? It's not like a decimal. I just reduce it as far as I can. And then so 75 degrees is 5 pi over 12. Okay, and that's all. Same thing with 220. I'm going to put him over 1, and then I'm going to either use pi over 180 or 180 over pi. Because I have degrees on the top, I'm going to put degrees on the bottom. So 180 has to go on the bottom, pi has to go on the top, and then I'm just going to reduce. First things first, I can just knock a 0 off. So I have 22 and 18 now, and then I can just divide by 2, I think. So 22 divided by 2 is 11. 18 divided by 2 is 9. And I think that's reduced as far as we can. So this would be 11 pi over 9. Notice I do not write it as a decimal. I leave it in radians as 11 pi over 9, okay? And that's what 220 degrees is, all right? Last one, C, I make this over 1, and then I'm going to do degrees on the bottom again, okay, because I want it to cancel here and cancel here. So I have to put 180 on the bottom and pi on the top, okay? I'm going to do the 0 cancel thing again. And then 40 and 18, let's just divide by 2 again. Should we do that? Divide by 2. So this would be 20, and this would be 9, and I don't think 20 and 9 divide at all. So I just go ahead and 20 pi on the top, and 1 times 9 is 9 on the bottom. So 20 pi over 9, that is the radian version of 400 degrees, okay? So that's how you convert from radians to degrees. The majority of your homework assignment is going to refer to that, okay? All right, the last thing is talking about arc length. So we're going to do this example, we're going to do example 6, and then we're going to save a linear and angular speed for whatever next week sometime, okay? So you will have some arc length questions on your homework assignment, and I'll show you which ones to skip over then, okay? So arc length is the length of the arc. So they're going to say, like, you have an angle that's rotating this much. How far is it from here to here? Okay, and this is what we're trying to solve for, like how far is that thing moving, all right? So let's talk through what they're asking us to do. It says the second hand on a clock is 6 inches long, okay? So this is my second hand right here, and this is 6 inches. How far does the tip of the second hand move in 15 seconds? So we're going from here to here, and they want to know, like, this distance, okay? I know that this distance is 6, but I'm trying to find this distance, okay? Those look like they're, like, pretty comparable, so this one might be around 6, like approximately 6 inches, right? Like that, this distance looks like it may be the same as about that distance, right? So I guess 15 seconds. 15 seconds would be to the 3, so I lie. Right? 15 seconds would be to the 3. So we're going like a quarter of a circle around. So it would be probably a little bit more than 6 inches, maybe like 10 or so, right? But we're trying to figure that out. So here's the deal. Let's say that second hand would go the whole circle, right? Like the whole distance around, all the way around the circle, all the way around, okay? If it goes the whole way around, that's going to be the circumference of the circle, which is 2 times pi times the radius, okay? Now, our radius is going to be 6 inches, right? Because they said our distance, or like our second hand on the clock, is 6 inches long. So if it would go the entire way around the circle, it would be like 12 pi, right? 2 times 6 is 12. So this would be the whole circle all the way around. But I don't want to go all the way around. I only want to go 15 seconds of it, right? Which is this much, okay? 15 seconds out of a whole circle would be 60 seconds, right? 15 seconds out of 60 seconds is the whole circle. And if I reduce that, that is 1/4 of a circle, right? Like we said that this was 1/4 of a circle. So instead of going the whole circle, which would be 12 pi, I only want to go a fourth of the circle. So I'm going to take that 12 pi and I'm going to multiply by 1/4, or divide by 4 basically. 12 pi times a fourth is actually 3 pi, and it's going to be like almost 10, right? Oh, shoot. 3 times, where's my pi been? Pi. 9.42 inches is how far it is traveling from here to here. And that's kind of what we said, right? Like this is 6, this has to be a little bit more than that because like lengthwise this looks more than 6 inches, okay? So the strategy here is to find the whole circumference and then multiply by the fraction of the circle that we want, okay? So my whole circumference was 12 pi, and then the fraction of the circle that I wanted was 1/4, which is 15 out of 60 seconds, okay? So that's how we find the length of the arc length. Put this like on your thing, okay? That's exactly how you find arc length, okay? Now going back the other direction, okay? This one is saying find the measure of the central angle, all right? So now we're finding, now they're giving me the arc length is 5, and they're saying, what's the measure of this, right? Like how big is that, okay? All right, so here's the deal. They're saying that the radius is 3, right? The radius is 3, and we're trying to find like what angle would give me like an arc length of 5, okay? All right, and the more you do these, the more familiar you become with this. So the deal here is that every radian, like if this was 3, okay, if this is 3 and I go 3 out this direction, that would be 1 radian, right? Like this would be 3 centimeters, okay? And you remember from the first example that many degrees is about 57.3 degrees, right? 1 radian. So like 3 centimeters here would be about 57.3 degrees, but I want to go 5 centimeters. So obviously we're going to be a bit bigger than 57, not quite double, right? Double would be 6 centimeters around, okay? So if I double 57, that would be like 114.6 or something like that. We're going to be less than 114.6 because we haven't quite gone double the distance, right? So what we have to do is we have to figure out the angle that we have going on there, right? Okay, so we said it's a little bit less than 114.6. We've got to kind of work backwards, all right? So here's the deal. Let's see. Okay, let's do this. I'm going to do this as a proportion. How about that? That might make this easier. So let's talk about the part that we have, and the part that we have, and the hole that we have, and the hole that we have, okay? All right, so I'm going to talk about degrees over here, okay, in this section, and then I'm going to talk about distance over here in this section, okay? So the part of the distance that we're talking about is 5 centimeters, okay? So I'm going to put 5 up here on the top. The whole distance would be the circumference, which is 2 times pi times the radius, okay? And in here, the radius is 3. So if I would go the whole distance, I would have 6 pi. 6 pi would be my whole distance. I'm only going 5 of it, but if the whole distance would be 6 pi. Now, if we talk about degrees, I want to know the degree measure, and the whole degrees, if I would go all the way around, would be 360, okay? So like 360 would be equivalent to 6 pi in this case because my radius is 3. Okay, and we're saying how many degrees is equivalent to 5 then? And then I can just cross multiply and divide, okay? So 5 times 360, whatever that is, 5 times 360 is 1,800. 1,800 equals, I'm going to call this x right here. X is the number of degrees that I have, okay? 6 pi times x, okay? And so I'm going to take, let's see, 6 pi. 6 times pi is 18. This is 18.85. Okay, if I divide by 18.85, 1,800 divided by 18.85, I get about 95.5 degrees. Okay. So I set that up as a proportion, like the part that I want over the whole and the part that I want over the whole, okay? So degrees on one side, the distance on the other side. Cross multiply and divide, and we got 95.5 degrees. Now let's go back to our estimation. we estimated 114 degrees. Okay, we said it has to be a little bit less than that because we haven't gone 6 units, we've only gone 5. 95.5 degrees sounds pretty decent, okay? All right, so that way is maybe a little bit harder, but you can just set it up as a proportion if you want to and do the central angle measure that way. So these both are going to be solving for arc length, okay? Arc length and central angle, those two are kind of hand in hand with each other, but reverse, okay? On your homework assignment, this front page should be fairly easy because you're just doing conversions there, or you're finding coterminal angles and that type of thing. If you go to the back side, you should be able to do 19 and 20 maybe, but these two are going to be ones that talk about, oh no, just 22 and 23 are going to be ones where they talk about angular speed and linear speed. So maybe save those for Monday or for when I get back or whatever, you know. But you might be able to try to get through the rest of them, okay? All right, I know that's a lot of information all at one shot. Radians are tricky until you master them, okay? So if you have questions, ask one of those 3 boys that's in my trig or my calc class. You can boost their ego a little bit because this is like the second time they've had this. So it might be a little bit easier for them than it is for you. So there you go.